Okay, in this lesson, I'm going to discuss how to expand and then find the exact answer using our double and half angles. So I'm going to do a few examples here from the last page of the uh, packet. So the first thing we notice here is they're giving us that sine of A is 4/5. It's in quadrant 2. They're telling us that the cosine of B is equal to 8/17. That's in quadrant 4. So I'm going to start with sine A is 4/5. So if you think about we're in the second quadrant, I'm going to just kind of construct a triangle here, and we're going to construct it in the second quadrant. And when we construct it, we know the sine of A is 4/5. Sine is opposite over hypotenuse. So the opposite is going to be 4, and the hypotenuse is going to be 5, which is going to make this other side of our right triangle 3. So it's a 3, 4, 5 right triangle. Actually going to make 3 negative because we're in the second quadrant. Um, if I were constructing my other triangle for cosine of B, and it's in the fourth quadrant, so when I sketch it, it's adjacent over hypotenuse, so the 8 is going to go here. Hypotenuse is going to be 17, and when you do the Pythagorean theorem, 8 squared plus what squared equals 17 squared, and you work that out, you end up getting 15. So that's going to be a negative 15 because we're in the fourth quadrant. So this is my sine of A picture. This is my cosine of B picture. So depending on which problem I'm working through will depend on which triangle I'm using. The first one is the sine of 2A. We're using our double angle formula here. So when I first of all expand this, it becomes 2 sine of A cosine A. And then from there, I'm just going to go back to my triangle. So I've got 2. Well, we know the sine of A is 4/5. They give us that. And then the cosine of A, cosine is adjacent over hypotenuse, so that's going to be a negative 3/5. And then I'm just going to simply multiply that out. So 2 times 4 is 8, times 3 is 24. And then that's going to be negative. And then 5 times 5 is 25. So that first one, sine of 2A, is going to be negative 24 over 25. Okay, let's look at number 2. 2 says the cosine of 2A. Well, if I expand cosine of 2A, again, I know on my formula sheet that there's 3 possible formulas. I'm just going to use the first one. Cosine squared of A minus the sine squared of A. So again, I go back to my triangle. Cosine of A is adjacent over hypotenuse. That's negative 3/5. And we're squaring it, minus the sine of A is 4/5, and we're also squaring that. So as we go through that process, negative 3/5 squared is 9 over 25. 4/5 squared is 16 over 25. 9 minus 16 is negative 7 over 25. Okay. Now let's do a tangent one, and then we'll do a double or a half angle formula. So tangent of 2A, again, my formula to expand that is going to be 2 tangent A all over 1 minus tangent squared A. All right, so if I fill in my values here, tangent A, again, I'm going back to my triangle. Tangent is opposite over adjacent. So that's going to be 2 times negative 4/3 on the top. Then on the bottom, we've got 1 minus a negative 4/3 squared. We do get a complex fraction here on the top. 2 times negative 4/3 is negative 8/3 on the top. On the bottom, I end up getting negative 4/3 squared is 16 ninths, which I get a common denominator, 9 ninths. 9 ninths minus 16 ninths is negative 7 ninths. To get rid of the complex fraction, I'm going to multiply the top and the bottom by 9. That's going to get me negative 24 on the top. And then on the bottom, that gets me negative 7. So when I simplify that, it's just simply 24 over 7. Okay, I'm going to skip down to one of the half-angle problems. So let's look at number 7. So number 7, we've got the sine of 15, and then again we expand that to half angle, so it's sine of 30 over 2. Now we know that our half angle formulas, the formula is plus or minus, and then the square root of 1 minus the cosine of 30 all over 2. Now this plus minus out front in both the sine and cosine formulas is all dependent on what quadrant we're in. So you'll notice here that's all based on this angle right here. So we're in the first quadrant, 15 degrees in the first quadrant. We know sine in the first quadrant is going to be positive, so I'm going to utilize just the positive. So the negative is going to go away on this one. If I then fill in what I know, 1 minus, I know that the cosine of 30, if I figure my cosine of 30, we know that that is just simply, cosine of 30 is radical 3 over 2 on my unit circle, and then over 2. And again, if I simplify this, I've got a complex fraction here, so I'm going to, under the radical, I'm going to multiply by 2 on the top and the bottom. So I end up now with 2 minus radical 3 all over 4. And then I can take the square root of 4. So it's basically the square root of 2 minus radical 3 all over 2. And again, it is going to be positive because we are in the first quadrant there. Okay, I'm also going to do number 8 just as another example for you. So we know that this is another half angle for cosine. So again, plus or minus square root 1 plus cosine of 210 all over 2. Now this one, again, as we look at the angle 105 is in the second quadrant, and we know that cosine in the second quadrant is negative. So we're going to keep the negative on this one. 1 plus, we know that the cosine of 210, cosine of 210 is in the third quadrant, and we know that we do the cosine of 210, that's going to be a negative radical 3 over 2. And then on the bottom, then we've got 2. Again, much like the last one, I'm going to multiply the top and bottom by 2. That's going to get me negative, and then 2 minus radical 3 all over 4. So our final answer here is going to be negative radical 2 minus radical 3 all over 4. I'm sorry, all over 2. We take the square root.